Yeah, here. These equations are not correct, so I don't know why they put these equations. So these are the correct ones. So this is the S, standard deviation, lower control limits, B3 S bar, upper control limit B4 S bar, X double bar, A3 S bar. Okay, so let's see this example. Consider the data shown in figure 832. These data represent measurement of deviations in millimeters from nominal specification for some machines. The value of one indicate 1 meter above the nominal, so on. Okay, so calculate, or this is a typical question I always ask. I give you data and then I ask you to calculate this control limits, even for X bar and R or X bar and S chart. So what you need to do, you just need to know where the equation, these are the equation for X bar and S. Okay, I put the equations. So I look at the equation. I need B3 before I go to the table and find these two values for this, the given sample size. Okay, a sample size of 10. So I need to go sample size of 10. Yeah, that's, I look at 10 here. So my A3 is 0.975. B3 is 0.284. B4 is 1.716. And later I will need this number for calculating, which is C4 for calculating the standard deviation. Okay, I calculate them and I do that. Let me see, show you the Excel sheet. Okay, so this is sample one. Okay, I put this sheet on the class website under this week. So to do this in Excel, of course, if I have this sheet, I have to do it in Excel. I cannot do it by hand. I just calculate the standard deviation for this sample, okay? And then I scroll this down to the right for each sample. I have 25 samples, okay? Then I calculate the the standard deviation, average of standard deviation, which is in this case, for my case. Even you can use this template, or I like to do my own work, okay? So this is S bar. You see S bar, this is S bar. This is S bar. This is A3. This is B3. This is B4. Oh, we don't need D2. I don't know. Okay. So now we can say, let's take these values. Of course, you can do everything in Excel here, but I will do it by hand. I will put these values somewhere here. Okay. So lower specification, lower control limit is equal to B3. B3 is 0.284 times 1.467. B4 is 1.716 times same 1.467. The control limit for R, we need to calculate X double bar. And as we said last time, I just need the average, right? The average is equal to average. And then I find the average for these numbers, which is here. Oh, the average is negative anyway. Just take it as it is. Okay. And plug in the A3 within here. And the S bar is already calculated. And the X double bar already calculated. And we can do this in Excel also. The central line is the average for this. This is the X bar. Okay. This is the S for the S chart. This is the standard deviation. Let me see if somebody is waiting. No, nobody is waiting. Let's take the attendance for today. Today is 3/21/24. Okay, I calculate them or I do this in Excel if I want. And then I plot these. So let me show you how to plot these numbers. Let me take all this stuff to a new sheet. Paste them as values. Okay, let's plot the X bar chart. I will start with the average, highlight the average, and then I go to insert. Okay, I select this. Okay, and then I go, I add what? I add the lower control limit, the name, the X, I don't need the X. I select the lower control limit here. Okay, the lower control limit or here. And then I add the upper control limit. So this is the upper control limit. And then I need the central line, which is the central line is the center, which is X double bar. Okay. This is the X double bar. Okay. So now I can add titles, access titles, whatever I want. Okay. So this is my uh, this is my X bar chart. Okay. I do the same thing. Your breath away. For the S chart. Just do the same thing. Take this down here. I take the center, for example. Go to insert and then keep adding select data. Add, you want to add the lower specific standard, the lower control limit. Set the lower, A7 the lower. Okay. Add the upper control limit. And the standard deviation. Then I can see if my chart is in control. I think this point is out of control. Here, everything is in control. Indeed. There are other charts, like for individuals. There is a chart for moving range, chart moving range, like moving average, where it tells you how to move two ranges or three ranges, and it's the same. There are like charts for attributes. So we said we have charts for variables. When you have variable, a variable is a variable. It changes like from uh, it can have any value, 0, 1.1. What attribute, you know, you have conforming or non-conforming, good or bad. So there are like charts for that. We have P charts, MP charts, C charts, U charts. Okay. So we said conforming or non-conforming is a single non-conforming quality characteristic. It does not conform to specification. Okay. So we use a fraction of non-conforming, which is P chart. Okay, the fraction is like if we have a bucket, we have 10 parts, two of them are not good. So the fraction of not good is 2 over 10. Okay, that's the fraction. So here they use the standard deviation, the pool standard deviation, and then they use a formula like this, which is P bar minus plus the rule standard deviation or the fraction standard deviation. It's similar to, there is also, and then the control limits P plus minus the 3 if the square root of P bar 1 minus P bar over N. And the same as we did in the, there is an P chart, which is number of non-conforming. This P chart is the fraction of non-conforming. Here the number. So I can have like 10% of non-conforming, but for the number I say, oh, I have like two non-conforming. Okay. So this is a fraction and this is a number. There is also a formula for that. There is a C. Okay. Count of non-conforming, count of non-conforming, it's the same. Compute the average number. So this is count C, standard deviation of C is the standard deviation of C is S, which is the square root of C bar, the average of count. And there is another chart called U, where you have number per unit area, number per unit area. There is a slide here for the equations. So for me, usually I concentrate on X bar and R, X bar with S always, if it's good to know about all these charts, but usually I concentrate on these two charts. It's good to have this table because it summarizes the equations for you. And this also, this slide is good where, you know, it tells you which chart to use. So if you have variables, so you use this left side. If you attribute, you use this side. Which type you need to use. If n is greater than 1, okay, so you need to use even X bar and R or X bar and S. So if X bar and if it is the sample size greater than 10, use S, don't use R. If it is less, then use R. Okay, here defective, okay. Constant sample size, no, use P chart. If it is yes, P or a P chart, okay. These are like when you change the sample size, probability of defection and standard deviation, you plot them. Okay, I think we are done for chapter 8. So what we did, I think we've been covering chapter 8 before the break. We had one assignment, and there is a small assignment here. Do it. This assignment, I put the data for you here. You need to calculate the X bar and R, and then find the X double bar in Excel, of course. And then does the data appear to be statistical control? You need to answer this question. But there's no CP and CPK calculations. I should have put some CPK and CPK calculations. But I think in this part, if there's none in this, I will add some questions where you need, oh yeah, there is some. Is there any question where I asked you to calculate the CP and CPK in these questions? I will add some later, but we are done with chapter 8. Okay, we'll do the presentations on Tuesday, and then we will go back to the primer and start cover some improvement stuff like hypothesis testing and other topics. Any questions? Questions?